recording. Okay, so here I'm just basically, I guess giving you a warning, so to say, about square roots. The square root of a sum is not the sum of the square roots. Okay, it's not. That's taking the square root is not compatible with addition, in other words. And basically, I give you an example there illustrating that. Okay, that's what I'm doing there. Namely, what I do is this. I take, okay, so A and B are positive. Okay, so I take A to be 1 and B to be 1. Well, the square root of 1, okay, A and B are both 1. So the square root of 1, that's just 1. You know, I think we've seen that before. Okay, now the square root of 2, that turns out to be about 1.4. Okay, I mean, you could check your calculator. That's what it turns out. Basically what I'm showing here is that if you take A and B to be 1, over here, you're going to have the square root of 2. That's the left-hand side, because that's the square root of 1 plus 1. Over here, you have the square root of 1 plus the square root of 1. And this is 1 plus 1. This is 1 plus 1, which is 2. So in other words, we have this. This does not equal this sum. So I'm just giving you an example illustrating that, the square root of a sum is not equal to the sum of the square roots. Okay? If A and B are both positive. I think it turns out if one of them is 0, then it is true. But again, if they're both positive, then we can't say the square root of a sum, we can't say it's the sum of the square roots. All right. I've seen people make that mistake. Maybe I did when I was an undergrad. I don't remember. But, I'm just warning you. I'm just, illustrating. All right. Now we're ready for the midpoint formula. Okay, so we're going to let P and Q be two different points, so they're not equal to each other, in the Cartesian plane. Okay? Then you can connect the 2 points by a line segment. Okay? So then you have a line segment with endpoints P and Q. That's what this denotes. Okay, this denotes the line segment with endpoints P and Q. The midpoint is the point on the line segment that satisfies this equation. So that the midpoint is a point on the line segment connecting P and Q, and its distance from P equals its distance from Q. So graphically, it would be on here, and the distance between M and P equals the distance from M to Q. Well, how do you find that? How do you find that point? It's actually not that bad because we have this formula. Basically, all you're doing is you're actually taking the midpoint, or the average, in other words, of the x coordinates and of the y coordinates. Notice you're adding. I've seen people in the past, they would subtract, so make sure you're adding, okay? So we have this new point. All right, well, let's do some examples. So here, so we're taking P to be the 0.14, Q is the 0.32, okay? Now, let's get the midpoint of that line segment connecting P and Q. The midpoint M of the line segment PQ, where P is this point and Q is this point. So again, it's just a formula from before. We have 1 plus 3 over 2. We have 4 plus 2 over 2, as you can see. right? So the x-coordinate, it's 1 plus 3 over 2, which is 4 over 2. That's just 2. The y-coordinates is 4 plus 2 over 2, 6 over 2, which is 3, as you can see. Now, let's actually confirm that. I mean, really have to confirm, that is, check M is on that line segment. I'm not checking that here, although I will graph it. I will show the graph shortly, but let's at least check this requirement. So the distance from P to M, right? Again, let's subtract the x-coordinates. We have 1 minus 2 squared. Doesn't matter what order. We have 4 minus 3 squared. Okay, so we add the squares together. We have negative 1 squared plus 1 squared, which is 1 plus 1. We take the square root of the sum, so we get the square root of 2. From M to Q, right? Here and here, we have 3 minus 2 squared, right? Subtract the x-coordinates. Subtract the y-coordinates. We have 2 minus 3 squared. So we get, and we're taking the square root of that sum. So we have the square root of 1 squared plus negative 1 squared, which is the square root of 1 plus 1, square root of 2. So you can see their distances are the same. That's good. I mean, again, you would normally have to check that M, P, and Q are on the same line segment. They're collinear, in other words. But for now, we could just do that by graphing. Okay, good. This graph this I made through GeoGebra. So, okay. I mean, there is a way to check that they're collinear without graphing. There's, I think, a formula, but I'm going to skip over that. Wait, sorry. So we have M. Sorry, I went too fast. We have M on the line segment connecting P and Q. I mean, yeah, this is a line, not just a line segment, but hopefully you still get the idea. Okay, here's another example. So, same idea. Let's get the midpoint of the line segment connecting P and Q together. Okay, all right. Now, so again, what do? We add the x-coordinates and divide by 2. So we have negative 1 plus 4 over 2, which is 3 over 2. And that's 1.5. We add the y-coordinates, see? Negative 3 plus negative 2. We divide by 2. Okay, that's what we're doing, negative 5 over 2. And we get negative 2.5. So I'm just using the midpoint formula. That's all I'm doing. So this is our midpoint. But let's just check at least this requirement. I mean, normally, again, you would have to see, is it on the same line as P and Q? But let's just check the distance part. So we subtract the x-coordinates. We have negative 1 minus 1.5 squared plus negative 3 minus negative 2.5 squared. Again, we're subtracting the x-coordinates, squaring. Subtracting the y-coordinates, we square. We're going to add these squares, right? So we have negative 2.5 squared plus negative 0.5 squared. We get this, but then we have to take the square root of a sum, and we get the square root of 7. From M to Q, same idea. We have 4 minus 1.5 squared, okay, plus negative 2 minus negative 2.5 squared. This is actually addition, if you subtract a negative. I probably should have written this as addition, but hopefully you still get the idea. So we have the square root of 2.5 squared plus 0.5 squared, which again is radical 7. So the distances are the same. And if you were to graph it, you would see, yeah, they're all on the same line segment. This I actually made through Desmos, this graph. So hopefully that makes sense, although I think it does. All right.